Hey again. Today we'll be covering the basics of how an ecosystem grows. Hence the title. Go figure. Now the nice thing about this is that once you understand the basic concepts here, you'll find that an ecosystem basically builds itself. There's not a whole lot of work you have to do to make a convincing one at all. At least not difficult work. It can be time consuming and slow since it's an iterative process where you'll be going back over the basics repeatedly, but it doesn't really require much thought for the most part, just some fairly simple stuff. So let's get started then, shall we? First off, you know that homework you did before? Yeah, the homework for the Playing Goddess series. You did do your homework, right? Yeah, you actually need some of that now. This was done in order for a reason, and that reason is you're going to use the previous steps to build up the next ones. So, specifically, what you need is a few materials to start with. What kind of materials are on your world? Do you have anything special, like mithril or other magical or science fiction based elements or whatever available? The reason for why we're checking is that anything that is available as a building block will come into use here in this initial stage of constructing flora and fauna. After all, you are what you eat, literally. If you don't have calcium somewhere in your diet, then you're not gonna have bones made of calcium, teeth made of calcium, or other body parts. Go figure. You can't make something out of nothing. Now, the first bits of life will be small, simple. We're not going to cover that stuff because it's not really going to survive long term to the point where your story takes place, probably. Or would be too small to matter. It won't leave fossils or other evidence of its existence, so for our purposes, it doesn't really matter much. What does matter is the energy source. Life requires that there be energy continually input into the system. Our sun soul works well for this. If you have other sources of energy such as geothermal heating, radiation, compression, stresses, it doesn't much matter what, just that you take these into account because your basic life, namely plants, are going to be feeding on this energy. If you have a big, bright sun, no big deal. Green, leafy plants with chloroform will develop pretty easily. Now, they may not start off that way, but by the time you're looking at sapient species evolving, your plant life will be pretty robust. If you have a dim sun, a star which really doesn't offer a lot in the way of visible light, well, you may get plants that are black, soaking up disproportionately more light. You may even get plants which recycle that light in a cyclical setup where they're bioluminescent. This is part of the ecosystem on the world of Nocturne within the Saorsa universe, which the Kayla species evolved upon. Their plant life has very little light to work with in the deep valleys of the mountain ranges and such, so they grow in colonies which generate their own light and heat so that they can feed off one another's waste products, thereby limiting how much new energy needs to be put into the system. On a planet with more than one star, or otherwise an overabundance of light, you may find completely different setups for your plant life. If there's no obvious light present, and your planet relies entirely on something like compression forces from a secondary orbiting body, such as a binary of planets, where one orbits the other, and specifically the second orbits in a direction opposite of how the first rotates, you'll generate a large amount of heat from the tidal forces generated. This would mean your plant life wouldn't have leaves intended to soak up light, as we see on Terra, but rather something more akin to large root systems, which benefit from the pressure squeezing them, perhaps with fluid which gets pressed through these elongated roots, or other compression-based or thermal-based chemical reactions. The point here is that your basic building blocks for your world's ecosystem will be plant life. That's where energy enters into the system and is first processed before animals even touch that energy. Food sources mean things which eat that food. If you introduce a new abundant energy source, soon enough you'll get some which can feed upon that food source, and not very efficiently at first, perhaps only as a supplement to its primary food source originally. But eventually, if there's enough of that food available, various species will adapt to make better use of it. Those individuals who can process the food better will be more likely to survive and produce offspring, and eventually you'll get more of them. So, our first tier of the ecosystem will be something which feeds upon a consistently available energy source. In our case on Terra, again, this is light and heat from the sun, which gets processed by plants into things like cellulose and other storage medium which hold onto it for later use. The next tier will be herbivores. These are animals or other plants which, genetically and anthropomorphically speaking, realize that it's a lot more work to process the energy yourself than it is to just eat something which is already processed. Why convert all that energy into cellulose when you can just eat the cellulose which is already ripe for harvest? Or in other words, why build a generator on your property when you have a pile of batteries already charged and present waiting to be used? So, our herbivores begin to nom on the plants. The plants which survive tend to be those with some sort of a defense, or those which benefit from being eaten. For example, a plant may generate a toxin of some sort, a poison which, as an insect tries to eat it, kills the insect, thereby saving the plant. Another example would be a plant where its seeds are eaten but can't be digested, and instead are crapped out by a bird far away, allowing for the rapid replantation of the plant. In both of these examples, this is a gradual process, and over each generation, those which happen to benefit from a randomly gained trait will tend to be the ones that survive. Each new generation, those with the best defenses or benefits, will be the ones most likely to survive and thrive. And so, too, will the same happen for the herbivores. The insect with a slight resistance to that particular toxin will tend to survive and still be able to eat from that plant as a food source. The next generation, the plants create a stronger toxin. The insects gain a stronger resistance, back and forth in a miniature arms race, which progresses until you get plants which are exceptionally poisonous, able to kill almost anything except for the one or two species specifically adapted to eating that plant. The same is true of the birds which eat the seeds. The plants which can signal to the birds that they want to be eaten will be the ones to have their seeds spread the most. So the plants start gaining tricks to stand out to the birds, but not to others. On Terra, this showed up as plants with vivid, colorful leaves, which only show up under ultraviolet light. The birds can see into the UV spectrum farther than we can, so when we see a green generic plant, they see a wonderfully colorful display that says "Eat me" all over it. Each generation, the birds which can see these markers for food better will survive better and reproduce more, and the plants with better markers telling the birds to eat them and better coatings for the seeds so that they don't get digested will be the ones that reproduce as well. And so our second tier is complete. And what of the third? Again, food is available. The insects and the birds which feed on the plants have meat, which is even more abundant in energy. It takes an awful lot of energy to digest plants still to turn it into meat. So why not just eat stuff which is already made out of meat? Enter the carnivores, the ones which feed upon the herbivores. This third tier of life will mostly feed on the second, which is adapted primarily to eating plants, meaning that the second tier isn't that much good at fighting back. At least not yet they aren't. These carnivores will grow to adapt in much the same way the herbivores did. Oh, those insects eat a lot of poison. Well, the carnivore which eats the insects will gain a resistance to that toxin as well over time. The insects may then develop a way to process that poison into a more refined, potent form, which makes them less likely to get eaten. The carnivore grows more resistant to this new form of toxin and specializes in eating this one specialized form of insect. Over time, the species gains specific traits which are based off of one another. This leads directly into the fourth tier, the second branch of carnivores which feed upon other carnivores. The fourth tier eats the third because the third is specialized in dining on small, easy-to-kill insects or other small game. The fourth tier are bigger, stronger carnivores which have found that carnivores need much more muscle than they need fat. And it's easier for these larger carnivores to eat other carnivores, which have already converted all that fat into muscle. This goes on and on throughout the ecosystem, with various branches breaking off, where you'll get a specialist carnivore which eats a specialist herbivore, which eats a specialist plant, which eats a specialized form of energy such as geothermal heating. Other sub-branches will form fungi which are specialized to live in the shade of a large tree and feed off its roots or bark, for example. Our fifth tier, however, is where the cycle ends and begins anew. Sooner or later, the carnivores get too big and too scary to fight. You don't want to try and hunt an eagle. So what do? You wait for it to die. Oh, flop. Right out of the sky and splat. There it is, just laying on the ground. It'd be a shame were a vulture to show up and nom on the dead body. Yes, the fifth cycle, the top of the food chain as it were, isn't the predator, but the scavenger in a lot of ways, because they eat the most deadly of carnivores and herbivores and anything else. Sooner or later, they too will die, and another tier will devour them as well, bacteria and microbes. Flies which lay eggs where their larvae, namely maggots, eat the necrotic flesh, and then when these die, well, all that nutrition winds up back in the soil which the plants used to grow. In the end, everything will eat everything else. But there must be a constant flow of energy being input into the system. Without that, none of this can happen. There's always a little bit of energy loss at each conversion point. So even though it's more efficient to eat something that is ideally preparing food for you, well, the problem is that still costs a little bit of energy to digest it, so you're constantly losing energy from the system. So you constantly have to have more new energy. What you'll notice, though, is that we started with an energy source, and then something which ate that energy, then something which ate the thing which ate the energy. On and on. Each creature eats the previous one, and each is affected by their food source and their predators in kind. The insects grow ways to hide from birds or lizards which eat them, blending into their surroundings with camouflage, for example. The lizards grow scaled hides and sharp bony protrusions to make it difficult for the eagles to eat them. The eagles gain longer talons and beaks, able to punch through the armored hide and get at the soft meat beneath. And this is why it's not difficult to build an ecosystem. You go through each basic tier, add a species or 3 based on the previous one, and then you move on to the next. The next tier does the same, basing its traits upon what the previous tier it feeds upon has. You get specialists which are only good at eating one thing, others which are more generalist and omnivorous, able to eat a wider range of things, with more genetic traits that are useful in more situations. And then you go through the cycle again, and again, and again. Each time you gain more nuance, more specializations, more traits which stand out. The ecosystem exists as a whole, but with each individual species competing against those on its same tier, defending against the tier higher up, and attacking the tier below. Each time you go through this cycle and specialize them a little more, you get more unique, more interesting, more real species. And so this is why it takes a long time to build up an ecosystem, but why it's also not that difficult to do. Come up with something that tries to eat your creature, and come up with a defense against that. Then see how those become exaggerated over time. What was just bone spines becomes poisonous spines, which eventually gain quills, which can be flung with a swing of the tail, to quills which can be fired via little gas sacs. You eventually go from a porcupine to what essentially amounts to a hydralisk. Evolution's an amazing process, and yet it's so simple too. If there's a food source available, random mutations will eventually lead to something which can eat that food. And as soon as that happens, the one which can eat a food source which is abundant and doesn't have competition, that species will thrive, and you'll get a population explosion. And then with the suddenly larger population will come more mutations, more specializations will form, and you'll probably get several different subspecies which each combat slightly different problems. And this is where your homework on the natural disasters comes in. You know how you are supposed to come up with 3 major disasters? Well, use them. Your species doesn't die out. But where it used to face this one predator and had some defenses against them, well, now it's split off. The Ice Age caused a temporary land bridge to form, and now that species is on the mainland rather than a tiny island. Oh, but you didn't think that was the end of it, did you? No, you made only the ecosystem for a tiny island. The ecosystem on the mainland is similar in structure, with similar rules formed, but different species. When they collide, the species now have new threats and new food sources, and those specializations gain new specializations on top of such. So, homework time. This is gonna take a while, just to warn you, but it'll be worth it. have 3 different biogenesis events on your world. 3 different plants which start from either the same energy source and feed on it in different ways, or different energy sources are taken advantage of. Build up each ecosystem a tier at a time, then go over each ecosystem in a few different passes. Afterward, apply 1 or 2 of your major disasters and mix some of your ecosystems. Sometimes the 2 will integrate entirely. Other situations may have only 1 or 2 species cross over to interact with a different ecosystem. Oh, and don't forget, if you added things like magic or unobtainium or whatever to your world, your creatures are going to eat that too. They're going to incorporate adamantium bone plates into their bodies. They're going to have vines which grow into complex magical circles of protection. They're going to adapt based upon those unique elements you added to your world. We're going to be on evolution for a while longer, so you'll have time to go through the iterative process. But yeah, this is going to take you a while. I do this professionally, and it takes me about 3 months on average to build a full world from scratch. It's probably going to either take you longer on your first try or 3 to get used to it, or you'll rush stages and it'll be faster due to not filling in the details far enough. There's a balance between how much detail you want and how much you want to leave to the audience to come up with on their own. And it's not a fixed point, so that'll take some time to get used to as well. The point is, if you follow this setup, eventually you'll have a living, breathing world full of diverse and interesting creatures that have never been seen before. You don't have to be that amazingly creative or anything to create unique creatures. You just need to follow the process of evolution in stages with multiple passes, and it really does basically build itself. Anyway, that's enough for this week. So with that, I'm out. I'll see you next time.